Right. A very good afternoon to all of you. Myself, Mehak Bhatia, Assistant Professor, IIMT College of Science and Technology, Greater Noida. Today, I'm going to give a session on the topic Topologies in Computer Networks. So, topologies is one of the very important topics in the subject computer networks. And today we are going to discuss on that topic. So, first we need to know, what do you mean by the word topologies? So, topologies basically means the arrangement with which the devices in the network are connected with each other. Let's begin. What is a network topology? Network topology defines how the network is structured and how the devices on the network communicate. Okay, so it consists of two parts, physical part and a logical part. A physical part describes the physical layout of the network, and the logical part describes how data flows in the network. There are basically two parts in the network topology. One is the physical part and one is the logical part. Physical part describes the layout of the network, and the logical part describes how data flows in the network. Both physical and the logical parts are known as physical topology and logical topology. And by combining both physical and logical topology, a network topology is formed. Okay. This is the structure or the map of the network. The layout of the cables connecting the network devices and computers are known as the physical topology, and the way in which the computers and networking devices transmit the data or the flow of the data is known as the logical topology. In this session, we are going to mainly focus on the physical topologies. Okay. So a physical topology is the geometric representation of all the nodes in the network. There are 6 types of physical or network topologies, which are bus topology, ring topology, star topology, tree topology, mesh topology, and hybrid topology. So we are going to discuss all these 6 network topologies in detail. Okay, so we will start with the very first topology, which is the bus topology. So a bus topology consists of various devices which are connected in a linear format with each other. Okay, as you can see in the diagram, there are 5 devices here as an example, and the devices are connected with a main cable here, a main cable which is known as the backbone cable. Okay, and along with the backbone cable, we can see one other type of cable with which the devices are connected with the backbone cable, which is known as a drop down cable. Okay, so one is the main cable and the other cables are the drop down cables with which the devices are connected with the backbone cable. Okay, now let's look at the characteristics of bus topology. A bus topology is designed in such a way that all the stations are connected through a single cable, which is known as the backbone cable. And each node is either connected to the backbone cable via a drop-down cable or directly connected to the backbone cable. So each node here means the devices. So in computer networks, we can call the devices as nodes or stations. So this is one and the same thing. Nodes, cables, or stations is the same thing. So the nodes are either connected to the backbone cable via drop-down cable, or they are directly connected to the backbone cable. When a node wants to send a message over the network, it puts message across the network, and all the stations available in the network will receive the message, whether it has been addressed or not. So let's understand this point with the help of an example. Let's see, let's suppose that this device here is called A. Okay, and the other device is called B. If A wants to send a message to B, it has to send it across the network, and all the other nodes can also access that message. So this is one of the feature of the bus topology, that the message sent across the network is broadcast. Okay. A broadcast means it is available for all the other devices as well, whether it has been addressed to or not. Now, bus topology is mainly used in 802.3 Ethernet and 802.4 standard networks. Okay, the configuration of a bus topology is quite simpler as compared to the other topologies. So this is one of the features of the bus topology, that it is simple. It is very simple to understand. It is one of the basic topologies that all the devices are connected with one cable, which is the drop down cable, and further they are connected with a drop down cable through a backbone cable through a drop down cable. The backbone cable is considered as a single lane through which the message is broadcast to all the stations. The most common access method of the bus topology is CSMA, which is carrier sense multiple access. Okay, now we have seen the characteristics of bus topology. Now let us look at the advantages of bus topology. So what are the advantages? Number one is the low cost cable. In bus topology, nodes are directly connected to the cable without passing through a hub or any other device. Therefore, the initial cost of installation is very low. In bus topology, no other device, extra device is used to connect the devices. Only the cables are used. Therefore, the initial cost is very low. So it is low cost cables are required. So this is one of the advantages. The second advantage is moderate data speeds. Coaxial cables or twisted pair cables are mainly used in bus network topologies that support up to 10 Mbps of speed. So it provides a moderate speed also. The next advantage is familiar technology. So bus topology is a familiar technology as the installation and troubleshooting techniques are well known and hardware components are also easily available. So the technology used in the bus topology is very familiar, easy to use. And the next advantage is limited failure. Now, limited failure, what does this mean? A failure in one node will not have an effect on the other nodes. Let's suppose one device in the bus topology has stopped to work. Okay, it will not have an impact on the other devices present on the network. So this is one of the main advantage of the bus topology, that if one device fails, it will not affect the other devices present in the bus topology. Okay, now let us look at the disadvantages of the bus topology. Number one is the extensive cabling. Now it is simple to use, but still lot of cables are required while using the bus topology, which becomes its disadvantage. Next is the difficult troubleshooting. It requires specialized test equipments to determine the cable faults. If any fault occurs in the cable, then it would disrupt the communication for all the nodes. Now, what does this mean? This disadvantage, what does this mean? That let's suppose there is a fault in the cable itself, then the whole network will get disrupted. The communication in the whole network will get disrupted. So this is a problem in the bus network, that if a cable fails, if there is a fault in the cable, then to determine that fault is difficult, and that would lead to the disruption in the whole network. Next disadvantage is signal interference. If two nodes send the message simultaneously, then signals of both the nodes collide with each other, which will result in interference of the signal. Now, let's suppose A sends a message across the bus topology, and at the same time, C also sends a message across the bus topology. Then the messages can collide with each other, resulting in signal interference. Next disadvantage is reconfiguration difficulty. Now, what does this mean? Adding new devices in the network would slow down the network. So a limited number of devices can only be connected in the bus topology. Adding more and more devices in the bus topology could lead to slowing down the network. So this is one of the disadvantages. Next is attenuation. Attenuation basically means loss of signal that leads to communication issues. And to resolve this attenuation problem, repeaters, a device known as repeaters, are used to regenerate the signal. So this was all about the bus topology. Now let's move on to the next topology, ring topology. So as you can see in the diagram, all the devices in the ring topology are connected to one another. Okay, they are connected adjacent to one another in a ring form. Okay, so that means the first device is also connected to the last device. In the bus topology, we saw that the arrangement of the devices was in linear format. The first and the last device was not connected to each other. Okay. Whereas in the ring topology, the first and the last device are also connected to each other. That forms a ring. Let's look at the features of ring topology. Ring topology is like a bus topology, but with connected ends. Okay, so the configuration is almost similar. The only difference is that the ends are also connected with each other. The node that receives the message from the previous computer or the node will retransmit it to the next node. Now, one of the very important characteristics is the data flows in one direction. That is, it is unidirectional in nature. Data flows in one direction only. The data flows in a single loop continuously, known as an endless loop. It has no terminated ends. Okay, there is no end point in the ring topology because the ends are also connected with each other. That is, each node is connected to other node and having no termination point. There is no termination point in the ring topology. Okay, the data in the ring topology flows in a clockwise direction. Okay, so one feature was that the data is going to flow in one direction only. And in which direction? Clockwise direction. So in ring topology, the flow of the data is always unidirectional in one direction and clockwise direction. Okay, the most common access method in the ring topology is token passing. Now, we have to understand what is token passing. Token passing means it is a network access method in which token is passed from one node to the other node. Now, what is a token in ring topology? Token basically means a pass. Okay, you can consider a token as a pass or an access thing. Let's suppose device A has a token, then only device A will have the access to send or receive data across the network in the ring topology. Okay, so whichever device or whichever node has the token will have the access to send or to receive the data. So a token is basically a frame or a pass that circulates around the network, and whichever device has a token will be able to receive or transmit the data in the ring topology. Okay, now let's look at the advantages of ring topology. Network management. Faulty devices can be removed from the network without bringing down the whole network. Okay, so we can easily manage the network. Let's suppose there is one faulty device, then it can be removed from the network. Okay, next is production availability. Many hardware and software tools for the network operations and monitoring are available. So the products are easily available. The hardware and the software tools used in the ring topology are easily available in the market. Next is the cost. Twisted pair cabling is inexpensive and easily available. Therefore, the installation cost is very low. So initial cost of developing the ring topology is not very much. The cost is minimal. Next is reliable. It is more reliable network because the communication system is not dependent on a single host. Okay, so it is a reliable network. Now let's look at the disadvantages. Number one is difficult troubleshooting. What does this mean? It requires specialized test equipments to determine cable faults. If any fault occurs in the cable, then the whole network would get disrupted. Okay. So this was also a disadvantage of the bus topology. And this is also a problem or a disadvantage in the ring topology. Next is failure. The breakdown in one station leads to the failure of the overall network. Okay. So let's suppose there is problem in one station. It could have an effect or impact uh, on all the nodes present in the network. Okay. Reconfiguration difficulty. Adding new devices to the network would slow down the network. So if there are less number of devices, only then the network topology or the ring topology will work properly. Otherwise, it could slow down the network. Next is delay. Communication delay is directly proportional to the number of nodes. So if we add more devices, there could be a communication delay in the ring topology. Okay. Now let's move on to the next topology, which is star topology. So as you can see in the diagram here, in a star topology, we can see one central device. This central device could be a hub or a switch, and all the other devices are connected in the network via this special device, a hub or a switch. So a star topology is an arrangement of the network in which every node is connected to the central hub or switch or a central computer. So there is one central device, one centralized node or one centralized device with which all the cables or with which all the other nodes are connected. The central computer here is known as a server, and the peripheral devices attached to the server are known as the clients. Coaxial cable or RJ45 cables are used to connect the computers. Hubs or switches are mainly used as connection devices in the physical star topology. So the devices which are mainly used in the star topology are hubs or switches. Star topology is most popular network in the network implementation. So it is one of the most popular topologies. Star topology is one of the most popular topologies. Now, what are the advantages of star topologies? Efficient troubleshooting. Now, what the problem in bus and ring topology is solved here in the star topology. Now, the troubleshooting has become efficient in the star topology. How? Troubleshooting is quite efficient in the star topology as compared to the bus topology. In bus topology, the manager has to inspect the kilometers of cables that are used. Whereas in star topology, all the stations are connected to a centralized network. Therefore, the network administrator has to go to a single station to troubleshoot the problem. So the network administrator doesn't have to look at all the cables, the extensive cabling which were present in the bus or the ring topology. Here in star topology, it just has to go to the centralized location or the centralized station and check out the problem if there is any. Next is, so this is the advantage of the star topology, that troubleshooting is efficient. Next is the network control. Complex network control features can be easily implemented in the star topology. Any changes made in the star topology are automatically accommodated. So the the complex network control features can be easily implemented. Next is the limited failure. Now, each station is connected to the centralized hub with its own cable. So let's suppose one node or one device fails, it will not have impact on the other devices in the network. Next is the familiar technology. Star topology is also very familiar technology and very cost effective, easily expandable. New stations can be easily added. So the problem which was in ring topology is solved here, that it can be easily expanded. New station can easily be added to the centralized server or the hub. Next is cost effective. It is very cost effective as it uses inexpensive coaxial cables. Next very important advantage is high data speeds. It provides the bandwidth of approximately 100 Mbps. Ethernet 100 base T is the most popular star network topology. Okay, so it provides higher data speeds as compared to bus and ring topology. Now, what is the disadvantage of star topology? A central point of failure. Let's suppose the main server or the main central hub or switch gets down or has some fault. Then all the other nodes connected to that hub will also get affected. So this is one of the most important disadvantage of the star topology, a central point of failure. Next is the cable. There could be some problems in the cable or cables also. So sometimes cable routing becomes difficult when a significant amount of routing is required. So this was all about the star topology. Now let's move on to the next topology, which is the tree topology. Okay, so as you can see in the diagram, a tree topology mainly consists of the root node. Okay, there can be one root node and various other peripherals or the child nodes. Okay, so one is the parent node and the child node. So parent-child relationship will be there in the network devices. So tree topology combines the characteristics of bus topology and star topology. So features of both are combined together to form tree topology. A tree topology is the type of structure in which all the computers are connected with each other in a hierarchical fashion. In a tree-like structure, the top node in the tree topology is known as the root node, and the other nodes, which are the descendants of the root node, are called the child nodes. Okay, there is only one path that exists between two nodes for data transmission. Thus, it forms a parent-child hierarchy. So there is only one path that exists between two nodes to transmit the data. What are the advantages? Support for broadband transmission. The tree topology is mainly used to provide the broadband transmission, that is, signals are sent over long distances without being attenuated. So, what does this means? That data can be broadcast here in the tree topology and it can be sent over long distances and the signal will not get attenuated. Okay, the signal will not lose its strength. The signal will not get disrupted over long distances. It will remain intact. Next is easily expandable. We can add new devices easily. Therefore, we can say tree topology is easily expandable. Next is easily manageable. The whole network is divided into different segments known as star networks, which can be easily managed and maintained. Okay. Next is error detection. Error detection and correction is easily possible in tree topology. Limited failure. A breakdown in one station cannot affect or does not affect the entire network. Point-to-point wiring. It has point-to-point wiring for individual segments. Okay. Now, what are the disadvantages? Difficult troubleshooting. Now, if a fault occurs in one node, then it becomes very difficult to troubleshoot the problem. Next is the high cost. Devices required for broadband transmission are costly. Okay, so here in the tree topology, broadband transmission is used. So which is costly affair. Next is the failure. A tree topology mainly relies on the main bus cable, and failure in the main bus cable will damage the whole network. Okay. Next is the reconfiguration difficulty. If new devices are added, then it becomes very difficult to reconfigure. Now let's move on to the second last topology in our today's topic, which is the mesh topology. So as you can see in the diagram, various devices here in the mesh topology are connected to one another in a mesh form. Okay. So a mesh topology is an arrangement of the network in which computers are interconnected with each other through various redundant connection. Okay. Here in the diagram, you can see that devices are connected with each other, interconnected with each other in a redundant fashion. Now, what does this mean? Redundant connection? That one device is connected to the other device uh, directly also and through other devices also. Okay, so there is a redundant connection. there is multiple paths from one computer to another computer. It does not contain any switch or hub or a central computer which acts as a central point of communication. There is no central hub here in mesh topology, or they are just the devices interconnected with one another. And the best example of mesh topology is the internet, where all the devices are interconnected with each other. Mesh topology is mainly used for WAN implementation, which is the wide area network implementations, where communication failures are critical concerns. Mesh topology is mainly used for wireless networks. Mesh topology can be formed by using the formula. So we can calculate the number of cables present in the mesh topology via this formula, which is n into n minus 1 divided by 2. Okay, so with this formula, we can calculate the number of cables which could be required in the mesh topology, where n is the number of nodes that are present in the network. Okay, so if let's suppose the value of n is 5. Okay, so there are 5 devices or 5 nodes present in the mesh topology. So how can we calculate the number of cables? We can calculate it with the help of this formula, n into n minus 1 divided by 2. So the number of cables, if n is 5, would come out to be 5 into 5 minus 1, which is 4 divided by 2, which would come out to be 10. So if 5 nodes are present, then the number of cables can be calculated. Okay. Now, mesh topology can be divided into 2 categories. One is the full mesh topology, and the second one is the partial mesh topology. In the full mesh topology, each network or each computer is connected to all the computers available in the network. So each computer is available to every other computer. So that would make a full mesh. Whereas in the partial mesh topology, not all, but few or certain computers are connected to other computers, with which they can communicate frequently. So all of the computers are not connected to all of the computers. Certain computers are connected to one another. Okay. So now let's look at the advantages of mesh topology. The first advantage is reliable. The mesh topology network is very reliable, as if any link breakdowns will not affect the communication between connected computers. So why is it reliable? Because there are various interconnections across the devices. So let's suppose one connection fails or one line's breakdown, then there is also a path. There is also a connection between the devices. There is also some other connection. So it becomes very reliable. Next is fast communication. The communication is going to be fast because there is interconnection between the different nodes. Easier reconfiguration. Adding a new device would not disrupt the communication between other devices. Now, what is the disadvantage? Costly. It is a costly affair. Mesh topology contains large number of connected devices, such as router, and more transmission media than other topologies. So definitely we can see if there are more interconnections between the devices, then the cost of cables would be high. Okay, the routing cost would be high. So one disadvantage is cost. Second is management. Now, mesh topology networks are very large and very difficult to maintain and manage. If the network is not monitored carefully, then the communication link failure goes undetected. Okay, so as we have seen in the diagram, there is an connection of networks. So management could be an issue here in mesh topology. Efficiency. In the mesh topology, redundant connections are high. That reduces the efficiency of the network. So efficiency could be a problem because there are redundant connection. A device is connected to B via many ways. So efficiency of the network could be reduced. Now let's move on to the last topology of today's session, which is hybrid topology. Now, as you can see here in the diagram, hybrid, what does the word hybrid means? Hybrid means combination of two things or various things. So hybrid topology consists of more than two topologies. When more than two topologies join together, it forms hybrid topology. Here in the diagram, two star topologies are connected with a ring topology network. So it becomes a hybrid topology. So the combination of various different topologies is known as a hybrid topology. A hybrid topology is a connection between different links and nodes to transfer the data. When two or more network topologies are combined together, it forms a hybrid topology. If similar topologies are connected with each other, it would not result in hybrid topology. Hybrid topology means two or more different topologies combined together. Okay. For example, if there exists a ring topology in one branch of ICICI Bank and bus topology in another branch of ICICI Bank, then connecting these two topologies will result in hybrid topology. Okay, now what are the advantages? It is very reliable. If fault occurs in one part of the network, it will not affect the functioning of the rest of the network. It can be scalable. Scalable means adding new devices to the network is easier here in the hybrid topology. Flexible. This topology is also very flexible as it is designed according to the requirements of the organization. This is very important feature or very important advantage that it is flexible. An organization can make a hybrid topology according to the requirements of the organization. Effective. Hybrid topology is very effective as it can be designed in a way that the strength of the network is maximized and the weakness is minimized. Okay. Now, the disadvantages of hybrid topology. Now, with the advantages comes the disadvantages also. The complexity is a problem here in hybrid topology. It has a very complex design because more than two or more than two topologies are combined together. So it will form a complex design. It is very difficult to design the architecture of hybrid network. Costly hub. The hubs used here in hybrid topology are very expensive, and these hubs are different from the usual hubs in the other topologies. So it is very costly. Costly infrastructure. Hub is also costly, and the overall infrastructure to build the hybrid topology is also costly. The infrastructure cost is very high as a hybrid network requires a lot of cabling, network devices, etc. So this was all about the hybrid topology. So we have seen various network topologies. We started from the very first bus topology. Then we moved on to ring topology, star topology, tree topology, and then we moved on to mesh topology and hybrid topology. So we have discussed all the features of the topologies, and this was all about the session. Thank you.